Section 7.3, page 397, try it yourself 1. Find the critical value t sub 0 for a left-tail test with alpha equals 0.01 and n equals 14. So this is a small sample because n is equal to 14. And so we're going to try to find the critical value and our critical region, which is going to be on the left-hand side because it's a left-tail test. So that means on the standard normal curve, it's going to be negative. So make sure you put your answer in as negative. And so here what we need is we need to know that it's a left-tail test because that means it's one tail. And we need to know that alpha is 0.01. And we also need to know our degree of freedom. And that's what the DF stands for. And to calculate that, you just do n minus 1. And that's going to be 14 minus 1, which is 13. So we're just going to go to table 5, which is the t-distribution table. T-distribution. Okay, so let's take a look at that. And so if we're looking for our critical value, it's going to be left tail, so we're going to put a negative in front of our answer here. We've got the degree of freedom is 13, and our alpha is 0.01, but I also know that's a left tail test, which means it's one tail. So we've got our one tail, 0.01, and we're going down to 13, so we get 2.650. So this is going to be negative 2.650. So our t sub 0 here, our critical value, is negative 2.650. This is section 7.3, page 398, try it yourself 2. Find the critical value t sub 0 for a right tail test with alpha equals 0.05 and n equals 9. Sample size is 9. And so to find a right-tailed test, that means we're going to have a tail, and you can imagine it as being a lot more perfectly symmetric than this. It's going to be positive. And we've got our alpha 0.05, our n is 9. So if our n is equal to 9, then our degree of freedom, because it's a small sample, is n minus 1, and that'll be 9 minus 1, which is 8. So we're going to look up alpha is 0.05. Right tail means it's a one tail. So we're going to go to table 5 and we're going to look up a one tail test. Degree of freedom is 8 and alpha equals 0.05. Table 5, this is our t-distribution. We're going to be a one tail test. Alpha equals 0.05 and degree of freedom is 8. So we've got a one tail test. The alpha is 0.05. Our degree of freedom is 8, and that's going to be 1.860. So positive 1.860, and so our t sub 0 is 1.860. 7.3, page 398, try it yourself 3. Find the critical values plus or minus t sub 0 for a two-tail test where the alpha is 0.01 and n is 16. So now we've got a two-tailed test. That means both the positive and the negative tails will be involved in this test. So there's going to be a negative over here and the positive over here. So we have two-tailed tests. That's how we're going to look it up in our table 5, our t-distribution. Alpha is 0.01 and n is 16. And so that means our degree of freedom is going to be n minus 1, which is 16 minus 1, and that'll be 15. And it's a two-tailed test, alpha is 0.01. And so we take a look at table 5. We have a two-tailed test. Alpha is 0.01 and our degree of freedom is 15. So right down here, it'll give us 2.947. And so that'll be the t sub 0 is plus or minus 2.947. So we'll have our 2.947 on the negative and 2.947 on the positive. Section 7.3, page 400, try it yourself 4. An insurance agent says that the mean cost of insuring a 2005 Honda Pilot LX is at least $1,350. A random sample of 9 similar insurance quotes has a mean cost of $1,290 and a standard deviation of $70. Is there enough evidence to reject the agent's claim at alpha equals 0.01? Assume the population is normally distributed. So the first thing we want to do here is to take a look at our claim. The claim is that the mean cost is at least $1,350. So that's going to be our claim. mu is at least. If I can pay you at least $10, I can't pay you 9. So it's going to be bigger than 10, but I can also be equal to 10. So that's going to be mu is greater than or equal to 1350. You're not worried about if you're not sure about your wording, just make up a little example. And so that means our null hypothesis is going to be that claim because it has equality in it. So it's going to be mu is greater than or equal to 1350. And so that leaves our alternate hypothesis, our H sub A, to be mu is less than 1350. And so we need to, let's first find our critical region and our critical value. So here's our standard normal curve. Draw a 0 here. And so this is a left tail test. This tells you that it's a left tail test. You always go by the alternate hypothesis. Again, this is our claim. Just going to put a little CL there. That's our claim. And so that tells us, the alternate hypothesis always tells us which way it's going to be. Whether it's going to be left tail or right tail or two tail, it's always the alternate hypothesis. And so this is going to be negative when we look it up. And so we've got to find our degree of freedom. And so we're going to need to start with our n here. Our random sample of 9 means our n is equal to 9. And so that gives us a degree of freedom of n minus 1, which is going to give us 8. So we've got a one-tailed test. It's one-tailed because it's left-tailed. And alpha is also very important here. Our alpha is 0.01. So let's go to our table 5. Alpha is 0.01. One tail, degree of freedom is 8. So one tail, alpha is 0.01, and our degree of freedom is 8. That gives us 2.896 for our critical value. So that's going to be negative 2.896 here. And now the next thing we do is we need to calculate our t. And the formula for our t is going to be x bar minus mu over the standard deviation divided by the square root of n. And so in this case, our x bar is our sample mean, which is 1290. Minus the mu right here is the 1350 divided by the standard deviation they give us of 70 divided by the square root of our n here we have is 9. And so let's put that in our calculator. We're going to do our parentheses 1290 minus the 1350 close parentheses, and then I'm going to do divided by. I'm going to do the parentheses again. I don't know if it's necessary, but I'm just going to do it anywhere. And the square root of 9. And that'll give us negative 2.571. And so that's our t, negative 2.571. So where does that go on our curve? Well, it's not in the critical region. Negative 2.571. So it's not in the critical region. That means that we do not reject the null hypothesis. So in this case, it means that there is not enough evidence to reject the agent's claim, since the agent's claim was our null hypothesis. Section 7.3, page 401, try it yourself 5. A company claims that the mean conductivity of a nearby river is 1,890 milligrams per liter. The conductivity of water sample is a measure of the total dissolved solids in the sample. You randomly select 19 water samples and measure the conductivity of each. The sample mean and standard deviation are 2,500 milligrams per liter and 700 milligrams per liter, respectively. Is there enough evidence to reject the company's claim at alpha equals 0.01? Assume the population is normally distributed. We're going to start with our claim, and here the claim is that the mean is 1,890. So that's going to start our null and alternate hypothesis. Since it's an equality, then the mu is going to be equal to 1890. And so that means that our alternate hypothesis is going to be not equal to. Mu is not equal to 1890. What other information do we have? Well, we also know that n is 19 because that's the number of water samples. We also know that the sample mean, or x bar, is 2,500. The sample standard deviation is the 700, and the alpha is 0.01. Another thing we have to conclude is that this tells us it's going to be a two-tailed test since it's not equal to. So let's draw our curve with our critical regions. Two-tailed test at alpha equals 0.01. Our n is 19, which means our degree of freedom here is going to be 19 minus 1, which will be 18. So our degree of freedom is 18. Alpha is 0.01. So let's take a look at a two-tailed test. Alpha is 0.01. Degree of freedom is 18 gives us 2.878. So that's going to be on the left and the right. Negative 2.878 and positive 2.878. Those are our critical regions, so now we just need to find our t. The formula for t is going to be x bar minus mu over s divided by the square root of n. We're going to use that s there. And so for us it's going to be 2500, which is our x bar, minus mu is going to be 1890 over s, which is 700, divided by the square root of 19, the n, not the degree of freedom. So let's go put that in our calculator. I'm going to use the parentheses there just like we had. The 2500 minus 1890, close parentheses, divided by 700, divided by square root, second x squared, 19, close parentheses, and we should end up with 3.798. I'm going to go with 3 point, and then the 8 makes the 9 become a 0, so that'll be 80, 3.80. So let's go with t is equal to about 3.80. So where is that going to end up? Well, that's going to end up over here in the critical region, 3.80. And therefore, we reject the null hypothesis. And something I forgot to do, you really should do, is to label the claim. And then this 3 dots means therefore. And here the company claims the mean conductivity is. And so our claim was this first one up here. And since we're rejecting that, then the question was, is there enough evidence to reject the company's claim? And you would say there is enough evidence to reject the company's claim. So there's enough evidence to reject the company's claim.